Hello everyone, I'm Ruhi Siddiqui from Department of Computer Science, Jamia Hamdard. Today I'll be presenting my research paper titled Exploring and Applying Browser Fingerprinting Methods and Their Countermeasures. This paper addresses a crucial issue in modern web privacy: how browsers unintentionally reveal unique user identities and what we can do to prevent that. So, browser fingerprinting is a sophisticated tracking technique that doesn't rely on cookies. It silently gathers device and browser attributes to create a unique digital profile of users. While this helps the website operators to understand user behavior, it also presents serious privacy concerns. So, in this study, I investigated how fingerprinting works, evaluated the defenses built into popular browsers, and developed a Chrome extension that introduces randomized data to disrupt the tracking attempts. Originally used by financial institutions to prevent fraud, fingerprinting has evolved into a common online tracking tool. Research by Engelhardt and Narayanan showed that around 80% of browsers have unique fingerprints. With big tech players tracking users across almost 80% of the websites, it's crucial to address the threat this possesses to privacy. Okay, so my research was divided into three phases. First was understanding how fingerprinting works by building a demo site. Second, evaluating the defenses in the Chrome, Firefox, Brave, and Tor. And the third was developing a custom Chrome extension that uses randomized values to disrupt fingerprinting. Tools like Cover Your Tracks and Fingerprint.js helped me guide the design and evaluation of my prototype. I explored three major anti-fingerprinting techniques used by the browsers. One was anonymization, that is, reporting common values like Windows OS to reduce uniqueness. Second is randomization, changing values across sessions as done by Brave. Third is disabling APIs, that is, restricting access to fingerprinting vectors like Tor and Firefox. I focused on randomization due to its effectiveness and user friendliness. The core of my project is Chrome extension that masks fingerprinting by modifying JavaScript properties like screen resolution, canvas output, and hardware details using randomized values. I also implemented real-time alerts to notify users whenever a site attempts to access fingerprintable data. Furthermore, all such attempts were logged and analyzed using backend server. Then testing the extension on real world sites and using automation tools like Selenium, I found that our extension successfully disrupted fingerprinting on major platforms like Cover Your Tracks, reduced tracking precision similar to privacy first browsers like Brave, and introduced no errors in over 50% of the websites and improved behavior on 9%. We examined the impact on complex sites like video conferencing platforms and multimedia sites. While most platforms worked smoothly, some video tools like Google Meet faced functionality issues due to randomized fingerprint data. Browser fingerprinting is surprisingly easy to implement and difficult to detect. While defenses like my extensions are effective, tracking methods are evolving rapidly. Techniques like favicon tracking are emerging, showing that even harmless browser features can be weaponized for surveillance. Future work includes smart error handling, dynamic decision making in the extension, and real time user approvals, similar to mobile app permissions. In conclusion, fingerprinting represents a growing threat to web privacy. My Chrome extension offers a practical, lightweight solution that effectively confuses trackers. With further improvements, such tools can become essential in defending user anonymity in digital age. Thank you for listening. Thank you so much. Hello everyone, I'm Ruhi Siddiqui from Department of Computer Science, Jamia Hamdard. Today I'll be presenting my research paper titled Exploring and Applying Browser Fingerprinting Methods and Their Countermeasures. This paper addresses a crucial issue in modern web privacy: how browsers unintentionally reveal unique user identities and what we can do to prevent that. So, browser fingerprinting is a sophisticated tracking technique that doesn't rely on cookies. It silently gathers device and browser attributes to create a unique digital